This is Joe Law with a research proposal for computer-aided instruction for teaching fractions to fifth graders. Initially, when I did my literature review, I did it for finding studies that show how computer-aided instruction had helped kids learn math. Well, I found several different studies, and they all used different types of software, and they all got different results. The one aspect that proved similar in all of the studies was that the more time the students spent using computer-aided instruction, the better they did on the post-test. I'm proposing a research project to find out if the amount of time fifth graders spend with math computer-aided instruction increases their proficiency in math, specifically for learning the addition, subtraction, multiplication, and division of fractions. I believe that having this type of data that proves or disproves that increased computer-aided instruction time increases proficiency in fractions will allow educators to make solid decisions about computer-aided instruction regardless of the type of software used. I predict that increased time with computer-aided instruction fraction software will increase math proficiency in fifth graders. I predict this will be the case because the computer-aided instruction will better engage the students. This research will take place in a local elementary school. Since the project involves school-age children, I will need to first obtain permission for access from the school and then from each individual in the study. After that, I will need to find teachers who are willing to participate. I'm proposing that 3 groups of 30 fifth graders are used as the sample sets. The first group will be the control group. They will receive all of their math instruction in the traditional manner with no computer-aided instruction. The second group will receive a 50-50 mix of traditional instruction and computer-aided instruction. The third group will do all of their math lessons using computer-aided instruction. The reason for using 3 groups is to show the progression that more computer-aided instruction equals better proficiency in math. If I only use 2 groups, it could be possible to discount the intervention group due to class size, the teacher, or equipment. To prove my hypothesis that more computer-aided instruction time equals better proficiency in fractions, the sample sets should show that the 50-50 class did better than the control group and that the 100% class did better than the 50-50 class. For data collection, to collect quantitative data, each of the 3 groups will take the same pretest at the beginning of the study and the same post-test at the end. The improvement in the post-test score will be used to compare the 3 groups. The teachers will take 2 surveys, one at the beginning and one at the end. These surveys will be standardized with the answers each correlating to a number so that a numerical score can be taken from the survey. The surveys will ask for the teachers' opinions on how this group of students compared to classes they have taught in the past, and how using or not using computer-aided instruction has changed the atmosphere in their classroom and how they normally teach their classes. The students will also do 2 standardized surveys. First, to get a baseline of their attitude towards math and what they like and don't like about math, and then the post-survey to see if there's an improvement in their attitude towards math and if things have changed on what they like and don't like. For the qualitative data, interviews will be done with the teachers at the end of the study to get a feel for their opinions on the computer-aided instruction and how it helped or impeded the learning process in their classrooms. The teachers will each receive a $50 gift card to Staples. Want the teachers to see and feel the importance of what they're doing, because that will be very important on the qualitative data collection piece, getting their opinions on how things went and what they would change. For the study design, I'll be using a pre-test, post-test controlled group with 3 groups instead of 2. The control group will have no computer-aided instruction. The 50-50 group will be half and half, and the 100% group will be all computer-aided instruction. The students and teachers will also take pre and post surveys. The classes will be randomly chosen for the control group, the 50-50 group, and the 100% group. For variables, the independent variable will be the computer-aided instruction. In this case, it's a software program called BetterMarks that's used for teaching fractions, or can be used for teaching fractions to 5th graders. And the dependent variable will be the increase in fraction proficiency from the pre-test to the post-test. For the procedure, the researchers will train teachers on the BetterMarks software. The pre-test and pre-survey for the students will be administered by the teachers and then passed on along to the researchers. The teachers will administer the intervention while the researchers observe and often offer input to the teachers as needed or if it's needed. The teachers will also administer the post-test and post-survey to the students and then pass those along to the researchers. And then the researchers will conduct interviews with the teachers after the end of the intervention. I've chosen a software called BetterMarks. I've chosen it because it has been used in other studies and it's widely accepted as an efficient method for teaching fractions to 5th graders. The 100% group will do all of their fraction learning in BetterMarks. The teacher will lead the class using their computer on a projector so that the teachers can see so the students can see what the teacher is doing and then follow along on their computers as well. The 50-50 group will do their first half of the lesson traditionally and the second half on BetterMarks, and this will take place every day during the allotted time for math for 1 quarter. For data analysis, for quantitative data, since there's only one variable, we use descriptive statistics to show the mean increase in score from the pretest to the post-test for each sample group. The same process will be used to analyze the change in standardized pre- and post-surveys. For qualitative analysis, the researchers will use coded field notes for their interviews with the teachers, and they'll use those coded notes to look for similarities and differences in what each teacher had to say about the interventions. I expect the results to show that the amount of time that was spent with the computer-aided instruction will directly influence the increase in score from pre to post-test. I also expect the 50-50 group to do better than the control group and the 100% group to do better than the 50-50 group. To maintain validity, the teachers will be well trained on the BetterMarks software. The pre-tests and post-tests are standardized, are tests that they would have used in their normal curriculum. And the researchers will observe the teachers administer the intervention and give feedback if it's needed. And there's still a chance the teacher may decide that BetterMarks isn't working for their class and abandon it because they want what's best for their class. I expect the groups doing the intervention to learn to do fractions better and faster than the control group, because the computer-aided instruction will engage the students better and they will learn more because of it.